Hi there, Year 11s. This is exercise 2F to do with family of straight lines from the Methods Cambridge textbook. And it's question 6. So question 6, we have a family of lines have equations of the form y equals 2x plus c. Okay, and it says where c is a number. So we know this is a number, and also this is a straight line because it says line, family of lines. So I know that this represents the y-intercept. So at the moment I don't know what the y-intercept is, but I do know what the gradient is. The gradient is equal to 2. Okay? First part of the question asks us to find the x-axis intercept of a line in this family in terms of c. So here we're really trying to solve for x-intercept. Now we know that to find the x-intercept, we know that the y-coordinate is 0. So we say substitute or let y equal to 0 into the equation. Now here's your equation again. You've got y equals 2x plus c. If you let y equal to 0, well then this is now 0 and you're trying to solve for x because you're trying to solve for the x-intercept. So here, what am I trying to solve for? The x-intercept, I'm going to minus c on both sides because it's a number. So whatever c is, it's positive c, so minus c on both sides. And what I'm going to get now is I get negative c is equal to 2 times x. And then finally, I want x by itself. I don't want 2x. So I need to divide both sides by 2 because divide is the opposite of times. And you can see 2 divided by 2 cancels out to be 1. And finally, x is equal to negative c on 2. And right there, that is your x-intercept. Okay, so therefore the x-intercept is equal to negative c. So whatever c is, whatever the y-intercept is, divide that by 2. That will give you your x-intercept. And that's what they mean when they say, find the x-axis intercept in terms of c. In terms of c means I want the equation to have c in it. Okay? All right, let's do the next part. So we've done the first part. We've now solved A. Let's have a look at B. So B says find the value of C if the line passes through the point 0.56. So again, same thing. So part B, they tell you to find the equation of the line. So y equals 2x plus c. That's what we don't know, but we do know it passes through the point 0.56. Was it 0.56? Yep, 0.56. So what that means is that this particular straight line, even though we don't know where C is, we do know there is a point where it crosses when x is 5, the y value is 6. So that's why in the equation we can say, well, that means in this particular equation, if I substitute x equals 5, then the y coordinate will have to be 6. So if you substitute that in, what you're going to get is you're going to get 6 is equal to 2 times 5, add on c, and now it's possible to solve for c. So we now know, okay, well then that's 2 times 5, which is 10, plus c is equal to 6. And you can see here, to solve for c, minus 10 on both sides, and you get negative 4 is equal to c. So what does that mean? That means this equation, if it's going to pass through 0.56 and it has a gradient of 2, the only way that's going to happen is if the equation was y equals to 2x minus 4. And I can prove that on Desmos. We can go to Desmos and test that out. So let's say y equals 2x plus c. So initially, we didn't know what c was initially. Okay, so c could have been any number, so any of these lines could have been c. But now we know it has to cross through 5,6. Where's 5,6? 5,6 is up there. So you can see the line doesn't touch it right now. So when c is negative 4, it doesn't touch it. If I go any more negative, negative 10 doesn't touch it. If I go more positive, it doesn't touch it. But eventually, there is a number that as I'm getting closer and closer to, it is getting closer to touching it. And we calculated it to be negative 4. So you can see that when c is equal to negative 4, the line does actually cross through 5,6. So instead of doing trial and error with this Desmos function, you can actually solve it by the way we just did. Okay, so that's what we were solving for. All right, and then now back to 6c. Let's have a look at 6c. 6c says, for which values of c is the x-axis intercept less than or equal to 1? So we want the x-intercept, okay, to be less than or equal to 1. All right, now remember, you already solved that in part A. Here's your equation for the x-intercept. And we want to know what numbers for C, so what C values can I put in to make sure that the result that the x-intercept is going to be less than or equal to 1. So here's an example. I can make up some hypothetical ones. Let's say C, okay, this is C and this is the x-intercept. According to the rule, if I chose C equals 0, right, hypothetically, then you would have negative of 0 divided by 2, because that's what it is, yeah? If C was 0, then it would be negative 0 divided by 2. That gives you 0. Now, is that less than or equal to 1? Yes, it is. So C could be 0. What if I changed it to 1? If C was 1, then I would have negative 1 on 2. Is that less than or equal to 1? That becomes, yes, that's negative half. So yes, that is 2. Well, what if I then changed it to 2? If I made it 2, then it's now negative 2 on 2, and I get, that's the same thing as negative 1. Is that still smaller than or equal to 1? Yes, it is. So you can see that there's a pattern here that the more I increase the number 3, 4, 5, you can see that there's a pattern that it's going to be negative 3 on 2, then negative 4 on 2, then negative 5 on 2. They're all less than or equal to 1 because they're all negatives. True? But then what about the other direction? Now, if I go the other direction, there has to be a certain point where something doesn't work. So let's say I try now negative 1. Then it'll be negative of negative 1 on 2. Yeah, because remember the x-intercept, the formula in part A you found was negative C on 2. So if C was negative 1, then you have negative of negative 1. So this now becomes half. Is that still less than or equal to 1? Yes, it is. And then what if I went to negative 2? So there'll be negative of negative 2 divided by 2. And you can see now this becomes exactly 1. So that's working. So it's definitely negative 2. But then as soon as I go to 3, now negative 3, we can see there's a problem. It becomes negative of negative 3 divided by 2. And that becomes 3 over 2, which is 1.5. And that's now not part of the result. Now, what I just did here, this is clearly trial and error. And there are times in mathematics, trial and error has its place. Right now, there had to be a better way than doing this. Okay, so obviously the answer is the maximum number is that when C is negative 2, it works. It gets exactly 1. So as long as the number is greater than, if C, whatever C you want, if the number is greater than or equal to negative 2, it should work. Okay, so that's just based on my trial and error. But there had to be a better way to do it. So here we go. Let's look at the statement again. It was x-intercept less than or equal to 1. But in part A, you already worked out what x-intercept was. The x-intercept was negative C over 2 less than or equal to 1. So what you're really trying to solve for is this inequality, which you learned back in year 9 and 10 on how to solve inequalities. You just got to be careful that when you divide or times by a negative number, you got to switch the sign. That's it, right? But you treat everything else the same. So here, if I were to solve it, to get rid of divide 2, I times 2 on both sides. 2 divided by 2 cancels out. You get negative C is less than or equal to 2. And then here, this is where it's important. To get rid of that negative, I'm going to divide by negative 1 and divide by negative 1. But remember I said here, if you divide or times by a negative number, the sign has to switch. So here, negative divided by negative cancels out. And C is, now 2 divided by negative 1 is negative 2. But remember the sign has to switch. C has to be greater than or equal to negative 2. And this was the algebraic way for a linear inequality to solve for exactly what I just did up here. So this was method 1. That was trial and error, as long as you understood what the question was asking. Method 2 was more direct. Okay? So that's what C is. So as long as you, question C, if you chose any number that was bigger than negative 2, you will guarantee that the x-intercept is less than or equal to 1. And you can test it on Desmos right here. So if I changed it, let's say it's minus 4. Oh, sorry, what am I doing? So I'll keep it as plus C. you can see here, if I zoom out, where's the x-intercept? So x-intercept is here. You can see 1 is, why isn't it showing? I just changed the step, so let's make that 1s now. There we go. So we can see where the x-intercept is. The x-intercept is over here. So that's 1. But the line, when it's -4, see how it's smaller than -2? We said that as long as c is bigger than -2, then it'll have a smaller, has a x-intercept less than 1. So you can see as I increase it, so I get to -2. Oh, look at that. It equals exactly at 1. Can you see that? At 1, 0, that's where the x-intercept is equal to 1. And if you now increase c, so if c is bigger than -2, can you see it's always going to be less than 1? That's the idea. So instead of trial and erroring with Desmos or with the table of values that I did in method 1, you could have done it algebraically to find out that point. When we'll see what values of c will make sure that you will have less than an x-intercept less than or equal to 1. Okay? And that concept there, that abstract thinking, that's what is the biggest challenge for students when they first begin Year 11 methods. It's that concept of being able to understand that c doesn't have to be a particular number. C can be a range of numbers. That's why it's called family of lines, right? And then finally, D, find the equation of the line perpendicular to the line y equals 2x plus c. So you got y equals 2x plus c, and you want it to be perpendicular. You need a line. You need to find out y equals mx plus c, another line that is perpendicular to this equation, and it passes through, where does it pass through? 0c. Okay, so now, first things first, for it to be perpendicular, remember, for these two lines to be perpendicular with each other, it has to follow the property that if they are perpendicular, then the gradient of one line multiplied to the gradient of the second line has to equal to -1. So m1 times m2 has to equal to -1. That's the property for perpendicularity. All right, and we happen to already know the gradient of one of the lines. So I'm going to say m1 is 2, right? So m1 is 2. What I don't know is this equation that I'm trying to come up with, this new straight line equation, I don't know what this m is. I don't know the gradient. So I'm going to call that m2. So that means 2 times m2, so whatever this gradient is, m2, I'll label it over here, m2, it has to equal to -1. So what would m2 need to be? So, well, some students struggle at this point because of the m and the subscript 2 there, but really you're just saying 2 times what equals -1. Well, you can actually solve it by dividing both sides by 2. 2 divided by 2 cancels out, and m2 equals to -12. So what that tells me is that this new equation that you're trying to come up with, okay, that's going to be perpendicular to this line, well, it's got to have a gradient that's -12x. I still don't know what c is. Okay, I don't know what the y-intercept is. But they did say it passes through the point 0c. Is that right? It says, find the equation of the line perpendicular to the line at the point 0c. Yeah. So we know that they are perpendicular at the point 0c. So both of them cross at the point 0c. So that means when x is 0, well, then the y value is c. So for both lines, so for y equals 2x plus c, and for the other line that we're trying to figure out right now, -12x plus c, we know that both of them have, when x equals 0, y should equal to c. So all you have to do now is substitute them in. When x equals 0, y needs to equal to c. And what do you get? You get c is equal to -12x plus c. And what are you trying to solve for again? You are trying to solve for the y-intercept, which is c. This is what you're trying to solve for. I'm not sure if those two c's are the same, but let's say if they are, well then, to solve for it, you can't really solve for it, can you? Is that even possible? I think unless it's a different c. And I need a sub-zero in. Sorry, I forgot to sub-zero in. So that means -12 times 0. So 0 plus c is equal to c. So therefore c equals c. That's funny. What's wrong with that? Well, then that's it. I don't think there's, there's nothing else. That means the y-intercept is actually equal to c. I guess they never gave you a number to begin with anyway. So in that case, yeah, your equation is equal to negative half x plus c. C equals c. It's just a weird way of writing it. I would say this can confuse a lot of students. I mean, it threw me off for a bit just now. But yeah, that's likely the equation that's going to be perpendicular to this one. So just to show you on Desmos to illustrate my point, right? So you got y equals 2x plus c. We don't know what c is, right? But I want one that's perpendicular. So like I said before, c doesn't have to be a particular number. It can be a range of numbers. So now if I wanted something perpendicular to it, remember it was negative half x, x plus c. So if I keep it like that, can you see how they're intersecting at perpendicular points? You see that? So if I made c 0, it's very obvious that they are perpendicular with each other right there. As you can see, they're crossing at 90 degrees with each other there. Or you can find, the gradient. Can you see how it goes 1 across, 2 up, and then same thing on this side. This also goes 2 across and then 1 down. That's showing its perpendicularity there. Okay, so you can see that no matter what c is, they're always going to be moving parallel to each other. Perpendicular with each other. See that? They're always perpendicular. So that's all they wanted you to find, that the second equation is perpendicular to the first equation. That's it.